Right, you ready? Ready for this? Stop chatting. You've had a chat about it, Cameron? Looking at the quadratic curve, here's the curve. What can you say about the coefficient of A? Obviously, that has caused some confusion. So I have to, I'm far enough away from your. The coefficient A, okay, come on, draw, right? A, small a, big A. Small a, big A. Lowercase a, capital A, uppercase A. Coefficient of A is the A in ax squared plus bx plus c. Okay, a coefficient is the number that you multiply the x with, not the coordinate on the graph. Okay, what do I know about A? If the curve is that way up, it must be negative. Done. Yeah, that's the first. And I know I can ask you that because I asked you that question in class. All right, we discussed that and you told me pretty quick, so I thought I'll chuck that one in. The reason why I chuck that one is because when you then want to do part 2, you know you're expecting an A coefficient that is negative. All right, why did I feel that was helpful? Well, because you're given 3 coordinates. 2 of those coordinates, here and here, okay, are where the curve crosses the axis. So you know that's where the factorized form relates to, okay? So you should, and a number of people did this, then if it's -1 here, you know it must be x plus 1. And if it's positive 15, you can see it, but you can also see it here. Okay, this must be x minus 15. But part 1 says there's a negative a involved, so let's find what a must be. So we put a, all right, and we use the 3rd coordinate that we haven't used so far, which is b, and b is when x equals 0, y equals 6. So we do 6 equals a multiplied by that. Well, actually, x is going to be 0, so I'm even just going to go 0 plus 1 and 0 minus 5. Yeah, I'm just picking up. Someone wrote 5 instead of 15 because they didn't. I can't remember who, but you know, it was you, was it? Okay. So I think you were going really well, and then just for the fact that you didn't check your own work, you missed on that one. Okay. What do we do now? Well, we solve for a. So this is 6 equals 0 plus 1, a multiplied by 1 multiplied by negative 15. So we've got 6 equals negative 15a. Looking good so far because it's a negative. Then a, come on computer, work, a equals 6 over 15, and it'll be negative. So that would be divide by 3 gives you 2 over 5. All right. So a is 2 over 5, which you can change to 0.4 if you like. So we could write it as y equals negative 2/5 x plus 1 x minus 15. That's factorized form. You know I wrote that first in the... I actually thought this through. I wrote that first. So because you were going to get to that bit first. All right. Or probably easier in this case is actually to do it with decimals. All right. Okay, that is factorized form. Equally fine if you'd have put this factor inside one of the brackets. I don't mind that, but you probably wouldn't have done that without getting to this stage first. Then we have to do standard form. What does standard form look like? The ax squared. So we just expand this. So I've got y equals negative 0.4. I'm going to just do the brackets first. That's x squared minus 14x minus 15, okay? If you then expand this, you get y equals negative 0.4x squared minus, so plus, I believe is 5.6x and then plus 6. All right, which is pretty good because why does it have to be a plus 6? It crosses at 6, and that's where we know the plus 6 bit, which is a good clue for the criterion D bit at the very end. Okay. So just in case you're looking for an alternative form, obviously we could have had, if we'd have used the 2/5, you'd have had negative 2/5 x squared. Okay. You'd have had plus 14 over 5x, and you'd have had still plus 6 at the end because you would have been expected to simplify. So decimals or fractions either way, but you've got, that's your standard form, and these are your factorized form. Okay. Owen, you did have another method which was fine, you just didn't quite manage to pull it off, which was Owen used the 3 things, and I believe used a method we have done, which is like working out the quadratic rule of a sequence. All right, so by using the ax squared plus bx plus c, he could say that for x is -1, so I've got 0 equals a multiplied by -1 squared plus b multiplied by -1 plus c, and then you've got the next one, which is 6 equals c in the end. So you get the c is 6 straight away, and then you get from 15, 0, you get 0 equals a times 15 squared plus b times 15, okay, plus c. Well, we've already got c is 6, so you can use your simultaneous equations method, which is what you were trying to do, yeah? You see that? Which would have done the same thing as well. All right, do you remember when we did our quadratic sequences and we went second line of difference, and remember doing that last year? Sure. No, you don't remember that? We will redo that this year, it's fine. But that was another method to come up with the same solution solving for simultaneous equations. All right. Anyway, any questions on that at the moment? Is that yeah, probably could have done that.
Yeah. I did something completely.
Is that yeah, I kind of get that. I should have known that that was coming up in the assessment based on the work that we've done. Well, that's not an inequality yet.
Yeah.
I wrote specifically the question for the inequality. I wrote write an inequality. Okay. This one is write an equation, which is not an inequality. Okay. All right. So that's an important skill to have. So all of your quadratic curve ones that end up being criterion D, all right. I had to sit and think about this one for quite a while to get you as nice a value of A as I could get. All right. Now you might think 0.4 is not very nice, but when you're using a quadratic to model a real world situation, that value that flattens the quadratic curve out has to be a decimal. All right. If it's a 2 or a 5, it just goes really high. And this is where we're then talking about the criterion D aspect of this problem, all right? That came up in it. But anyway, let's use your answer to question 2 or any other valid method to calculate the coordinates of the vertex. So you could have done completed square form, all right? We do have an equation of y equals, what was it, 0.4x squared plus 5.6x plus 6, right? You could try and do completed square form because you know that's vertex form. That wasn't what I was intending. What I was intending was, you know the x coordinate is where? How do I know it's 7? Exactly. It's halfway between -1 and 15. All right. So that was your first kind of conclusion. So I know the x coordinate is 7. How can I use an equation that I worked out in part 2 to find the y coordinate? Then substitute it in. So we get y equals -0.4 multiplied by 7 squared plus 5.6 multiplied by 7 plus 6. And you get y equals, I can't remember exactly, 20. Can someone do it for me? Can you work it out? It's like 25 point something, I think. Okay. All right. Did I? So calculate the coordinates of the vertex. So we should write correctly a set of coordinates. Right. If we were doing criterion C as communication, then I would pick you up if you didn't write it as a set of coordinates because I've asked you for a set of coordinates. Okay. But I didn't. And it doesn't matter anyway. Yeah.
What would have happened if we used the graph and tried to read the graph to get?
You can't. That's the exact point. It's a decimal value. You can't do that. Right. Also, it says use your answer to question 2 or any other valid method to calculate. Right. As soon as that word calculate, you know you're going to have to do some calculate. If I'd have just written find the coordinates, there's a chance that you could just look on the graph and find the coordinates. Yeah. But, yeah. I didn't intend you to read any coordinates from the graph. I just wanted you to see the shape. Right. I even gave you the other coordinates written down. Right. Make sense? Any questions? Easy enough to do. Even if I was marking this properly, if you got an answer, it says use your answer to question 2. So even if you'd have used your equation, if your equation was wrong, so you can give yourself credit if you know that you had an equation, even if it was wrong for part 2, but you used it to find the y value, right? The x coordinate is kind of a given. You can't come up with a different x value, but the y coordinate could have been if you'd have used your equation, not tried to read the graph. Okay. Hence, write the equation of the function in vertex form. Well, that would have just been, well, we know the coordinate of the vertex is 7, 25.5. You said, I don't recognize that number, but I'm going with it. So vertex form is the y equals ax minus h plus k. Recognize the completed square form, vertex form. So we would then have y equals negative 0.4. There should be a squared there. X minus 7 squared plus 25.5. Not much space there because there wasn't much working out to do if you understood completely. Does yours have more space than mine? Yours has a lot more space. But that's it. Like I said, you could have rewritten it. For instance, if you'd have done like vertex form for part 3, you'd have already had it. And you'd have worked that out, yeah, if you'd have done it correctly. Any questions on that, or you're good? Yep.
I just wanted to say that if I didn't get most of that straight because I didn't do the proper process for number 2, like.
I think everyone's the same.
Yeah.
No one did the right equation for number 2. Yeah. Yeah. Yeah.
Is the a just times by the x minus h squared, or is it?
Yes.
Okay, there's no full brackets. Right?
No. But that is something that I would expect you to think about, yeah. But
You didn't complete a square form.
But if you remember, when you do completed square form, you don't actually have it in vertex form until the very end.
Okay.
So when it's all in its brackets with the A on the outside, it's not completed yet, is it? So the number inside the brackets is not the coordinates of the vertex.
Yeah.
But yeah, good point. It's something to consider. Yeah. It's actually nice. It's a bit easier, is it? Because otherwise that would have been a bit trickier, right? So yeah, once you have the vertex and the other foot, it's super easy. All right, so that was your criterion A stuff. All right, not too tricky. Now we've gone through it.
It was just,
All
I
good.
made some silly mistakes. And
I
didn't
think you
understand
just
that
didn't
process.
remember. They're not silly mistakes. Let's get that right. They're not silly mistakes because you all did them and you didn't know otherwise. All right. The only silly mistake I spotted was Satya's writing 5 instead of 15. That's a silly mistake. All right. Getting things wrong because you don't really know the method is not a silly mistake. I've said that before. If you claim everything's a silly mistake, you're basically giving yourself free license not to study it again. I won't do that next time. Only you do it next time because it wasn't a silly mistake.
I think I made a silly mistake in the.
What when you have to mark a question like this, I kind of have to read in detail what you're saying and gain what you're trying to explain. Because there are lots of different possible things that you could say that I could give you credit for. So there's no correct answer in terms of, right, state whether you think the shot would be. I'm not asking, will the shot be successful? I'm asking, do you think the shot will be successful? So your answer, yes or no, is irrelevant. Okay? You'll notice the yes or no is not in the criterion D. It's about, have you identified all the possible elements? Yeah? And I think on the whole, a lot of you were taking that into consideration. Yeah? So you've got yes, you think it would, because, right, if we do go back to the graph, I'm not going to write much here. It's on the video. I'm recording. You can always review the video. If we go back to this thing, right? So zoom in on the graph. All right. So the idea is I've given you some information. All right. And some of you started to do this, like the hoop is here, right? So the ball is actually underneath the hoop. All right. Although, is that the hoop or is it the backboard? And I think a lot of you kind of came to the conclusion that actually this on here at 0 is where the backboard is. All right. Therefore, the hoop could extend a bit further. How far? So that is about
8 inches out.
So over a foot, yeah? Because this axis is all in feet, right? So you kind of like, is it 1.5 feet?
Yeah.
All right. Now, if you know anything about basketball, if the ring is 18 inches, there's also a bracket, right? The hoop is not directly on the backboard. So we could argue potentially this hoop could come all the way out to almost 2 feet. Right, now what do we notice? Yeah, all right. So that's one, or that's a couple of relevant real elements of the real life situation, discussing the fact that although this point is under where we think, that's not where the hoop actually is. All right, that would be taking it too literally as a kind of mathematical number, but we're dealing with a real life situation. All right, I gave you all those numbers to enable you to discuss that kind of stuff.
Yeah,
all right.
I didn't realize that you were talking about that graph. Like, for some reason, I thought they made this picture.
Oh, the picture I literally put in to give you some context to what it looks like. Yeah.
Well, what I did was I thought like the basketball hoop started at like 0, 0 when the backboard went up from on the y-axis all the way up 0, and the hoop extended outwards on the x-axis. So then I started talking about how the shot can like bounce off the backboard and go.
Well, yeah, I'm getting there, guys. So the things to consider, you could mark this on your graph and say, well, now it looks like the ball will go through the hoop. All right, because the hoop is not zero distance away. You know, it's not at 0, it's a number, right? You could then argue and say, right, the ball itself is however big. Potentially it might hit the rim. So you might say, no, you don't think it's going to be successful because even though the hoop comes out, it might hit the rim and bounce off, right? So that's where yes is an answer, no is also an answer with a given reason, okay? Anything else to consider that we're not making assumptions with no evidence?
Since the basketball is 10, if it goes past the center point of the ball, it's a good, we know it's going to go through, but if it's past, like if it's behind 5 centimeters of the ball, we know it's going to bounce off.
Yeah.
Because the center is not over.
Yeah, I mean, you could go into some real details. You could put numbers in to your equation if you really wanted to get serious about it and say, right, here, look at 1 foot, right? Do we think that's roughly, you know, you could have taken measurements. If the center of the ball is in the middle of the hoop at 1 foot, then I'm good, right? If it's 10 foot, the center of the ball is where the line is. Is it though?
Or it could be the ball could be.
Yeah, you could argue that this curve actually, I didn't say it was the center of the ball. You could say, well, if the line is the center of the ball, this is what it's doing. If the line is actually the bottom of the ball, it could be like, you know, again, I didn't make that decision for you. Yeah.
This is something that I don't think it would really apply to this question, but like in general, if you're playing like outside, if you're playing basketball outside, you would have to consider like the wind and stuff and how that could affect
Yes,
the ball.
but,
It doesn't really affect
well,
the ball.
it doesn't, but it can do later on, because the reason why I say it doesn't affect this question is a stepping stone. I have told you in this question, the ball follows that path. It does. Regardless of outside influences, the ball does follow that path. I'm not asking you to discuss whether or not the ball follows that path. I've told you it does, and I want to know whether you think that would be successful. And that's purely down to, do you think it's going to actually go through the hoop? And you could argue, you know, this point's slightly off, but I think the backboard goes up because I know what basketball's about. Right, it could still bounce off the backboard and go in. It's in the right general area. You know, no one actually knows, but we can give our now. I am after your opinion. Do you think it will be successful with reasons? And all you need to do is, yeah, the ball looks like it's in the hoop at that stage. The hoop extends out from the backboard. You're identifying relevant elements. Does that make sense? Yeah, nothing too much there. All right. All right, I've not asked you about the validity of this as a problem yet, but I know you'll kind of want to discuss that. Sorry, let's do it this way. All right, so would you like me to pause at that stage so you can write any of the notes here, or have you done what you need? No pause? We're okay, I'm not going to write it down. We've discussed it. All right. There you go. It's one for Liam. An 11-foot tall board is placed between the player taking the throw, and it might be an unrealistic situation. I made it up because I wanted an inequality. Okay, so basically the situation is, you could do a little sketch. Here's my curve. Okay. All right. Let's say, what was it? The hoop is at 10. All right, we know the height is 25.5 feet. Somewhere a board is going to be placed. Now, it could be placed near the hoop. It could be near the start. It could be anywhere in between, right? So we've basically got a region where it could go.
It could go right in front of the players all the way out.
So I want to know, where could I put it, but it not impede the ball? And I've also put write an inequality that describes the situation. Right, so what do we write? Chat?
So we have our equation with
Negative, so whatever your equation is, plus 5.6x plus 6.
and that line, we want to find where it's greater than 11.
Yeah. That's it. Must be greater than 11. That's your inequality. Yeah. So no, it shouldn't be and equal to. I just wrote that just out of habit. All right. It should not be and equal. Well done, Aidan, for picking me up on that. Why not and equal to?
Because it would be negative.
Okay.
You could argue that that's not right because if it's the center of the ball, then the edges of the ball will bounce off.
Yeah. Definitely you could argue, but this is a simplistic situation at the moment. That's why in part B, I have said by solving the inequality, show that there is an approximately 12-foot long space in which the board could be stood up. So that's that region somewhere between the hoop and the player. All right. There is a 12-foot approximately in which the board could be stood up. Right. So you're showing that there's a 12-foot space. So if you think about it, again, if you made a sketch, which I like to do, here's your curve. Here's the line that is at 11. What you're looking for are the two solutions, right? X1 and X2. Solving your inequality. All right. So how are we going to solve this inequality? Well, I gave it you. All right. Didn't tell you, but I thought, well, I did tell you at the beginning of the class, right? So we've got negative 0.4x squared plus 5.6x plus 6 needs to be greater than 11. So what do I do first? Are you desperate? Because I'm not going to stop. Hurry up then. All right. What do we do first? Minus 11. So we've got negative 0x squared plus 5.6x. We take the 11 away and we end up with minus 5. Well, let's just call it equals 0. All right. Put it in here. So A is, well, we know that one. That's the magic negative 0.4. B is 5.6. C is negative 5 now. Put that in, we get x equals minus 5.6 plus or minus the square root of 5.6 squared minus 4 times negative 0.4 times negative 5, all divided by 2 times negative 0.4. Is there going to be any issue just considering the determinant here with solving this? Well, we can't really, because actually there's negative here and the negative make the whole set of brackets a positive, and then we've got this minus a positive. So if this is bigger than this, then we've got a problem, but we don't know yet. But yeah, exactly. Your number sense then comes into play, doesn't it? And say 5.6 squared is definitely going to be bigger than 4 times 5 anyway. And then I've got to multiply by 0.4, which makes it even smaller. So there won't be any issues. So over to you. Find my two solutions, however you like. Okay. what did I say? 958 and x equals 13.042. They're the two solutions, x1 and x2. So you'll notice it says in the question there is an approximately 12-foot long space. Approximately. So x1 is 0.958 or 1. This one's 13.042 or 13.
So
12-foot space where it could go. Yeah?
yeah.
Make sense?
Yeah, with those two, I think it is exactly 12 feet. You subtract.
But like it's, remember we've added a bit onto that one and subtracted a bit off, so it, you know. Also, the approximately bit, well, that doesn't take into complete consideration the ball width, but the fact that it slightly is, and it says it's approximately 12-foot space, that gets through it, doesn't it? Yeah. Liam?
What I was gonna say is, I just had a question. Could we, this is just for what I did. I have a negative square root of 8 over 8. Could I cancel those out?
Negative the square root of 8 over 8. No. You're doing the surds yesterday. It doesn't work like that, does it? With this, guys, I would just, when you're dealing with decimals and you've got your quadratic formula, it just goes into your calculator, but do it step by step. Don't try and do it all in one go. Yeah. You will have to round it, so try and do the bit that you round at the last possible moment. But that's the trouble with the quadratic formula. If you're trying to find solutions, it can lead to slight issues, right? But I get over it with this word approximately. All right. Now, just to finish us off, okay. I think you guys were all finished off way before this. It says, state possible improvements to the model. How could you change the function that describes the shot? Gives reasons for you. So I'm actually looking for, right, what could you do? So this is really like the level 8 question. All right. This is where maybe you're going to go, how am I supposed to know that? Right. But you'll know that if you went and did a bit more research into quadratics and things. By the end of the course, we'll have done a lot of work on transformations of functions. You have done some work on that. All right. But there's basically one obvious thing that I was thinking about. So we've got a function y equals, we'll get there, 4x squared plus 5.6x plus 6, right, negative. There's one real obvious improvement, which I was looking for. This guy, where's he stood?
Free throw.
How far away from the basket?
12.
Where's the ball when he starts throwing it? Is it at his feet?
So you only have to add the initial.
So look, this is where he was stood, but where's the ball? He's basically kicked it. So where do I actually want it?
So the ball would actually.
I want it to be probably, again, 6 or 7 or even 8 foot. Yeah, depending on what you decide. I would like it to start up there. There's a really simple way of doing that, which is to add 7 foot onto the end. So it becomes negative 0.4x squared plus 5.6x plus 13. However, does that improve my model?
Yes.
It improves one end, but what has it affected?
The other end.
The other end.
So now you.
If you decided it went into the basket before, maybe it's not going to. Maybe it hits, but it's actually now 7 foot taller at the other end. So this is where we would go, all right, now we need to adjust other factors, yeah? We probably need to bring it narrower. So this is where I really had to think about what the equation was, because if we look at the original graph, if this now starts up here, follows the same shape, it's now probably going to be too high. So we probably need to bring this point in a little bit. All right, maybe make it do this instead. Yeah, roughly. So I'm going to have to change my A coefficient. I'm probably going to change, lots of different things. And that's where you can discuss it. At this stage, you probably wouldn't actually be able to give me a new function that's perfect, but you can at least make those suggestions as the final question. Everything make sense? Ready for a new version? We'll come up with a date.
Maybe.
Next time I won't give you as much guidance in the questions. I'm thinking I might allow you to have access to Desmos though, which does mean I can make it harder.